Good morning, good morning.
Morning, sir.
Good.
Morning, sir.
Okay. All right, let's do this. As you know, we're on vectors, and this is a revision class of vectors and a practice session. And it's about doing past papers and getting in some practice, as usual. And you know what it is. You need to go and redo the questions after I do them. All right, that always is a plan, the method. So this is actually the January 2023 paper, January this year, 2023. And this is the vectors question on that paper, number 10, and it is part B of number 10. That's our vectors question. You can see part A is matrices. And so you see that the matrices and the vectors, they always come together on the last question. That's what the syllabus is set out. All right, so this is it. So remember now, I like the vector, the diagram ones, because you can see your way around. And at this level, vectors basically just how you go from point to point. That's what a vector is. How do you go from point to point? And you want to go along vector direction that you know. All right. So in this question, it says the diagram below, in the diagram below, OPQ is a triangle. So this is it. OPQ right here that they're talking about. That's OPQ. And ARB and AOQ are straight lines. So this is a straight line. And this is a straight line. So you have some collinear points there, right? So these points, for example, are collinear. Right? They're on a straight line. But let's continue. It says B is the midpoint of PQ. So this point divides this line in two equal halves. That's midpoint. And so, for example, PB is going to be half of the PQ, because B is a midpoint. All right? So, we can see that. And it says R then, again, is the midpoint of AB. And so R is now the midpoint of this line. And what happened now is that, for example, AR is going to be half of AB. Half of AB. This is the whole AB. And this is half of it. All right? So that's the midpoint. So we have to retain that information, that this is a midpoint and this is a midpoint. All right? That information is going to become relevant at some point. Then they tell us a ratio. OR to RP is 1 to 3. OR to RP. So this is OR, this is RP. They are in the ratio 1 to 3. So if I were to put the ratio that they gave me on the line, which is a nice way to do it, put the ratio on the line. So this is 1 part, OR is 1 part, RP is 3 parts. So the total parts on this line is 4. 1 plus 3 is 4. And so it means that this piece is 3/4 of the whole line OR. And this piece is 1/4 of O, not OR, OP. So this is 3/4 of OP. That's right here, this piece. And down here now is 1/4. And so we can actually write that information. We can write that information since we deduced that from the ratio. 1 to 3, 4 total part on the line. And so let's write that information based on this ratio. But we are deducing from this ratio is 2 things. That OR is 1/4 of OP, and that RP is 3/4 of OP. And then they make it nice now. They make it nice by telling us that OP is actually 4A. OP is 4A, you know. So if OP is 4A and it's in the ratio 1 to 3, that means that this piece is vector A. So I can actually put it on the diagram. From here to here is vector A. I put it on in red and tell you if you see it. Because this is 1/4 of the 4A. So this vector from O to R is just A. I'm putting it on the diagram, A. And so the vector from P to R now has to be 3A because the whole thing is 4A. So this has to be 3A. This vector here is 3A. But good so far? But good at that? That breakdown?
Yes, sir.
The A and the 4A? Good. And then it says OQ is 8B. That's right here. This is 8B. I'm going to put it on the diagram. OQ is 8B. All right. So that's what we have so far. All right. And this would have given us the OR if we had placed the 4A here for the OP. We're going to get the A. And similarly, if we had placed the 4A here for the OP, we'll get the 3A as well. All right. So that is consistent. All right. So let's answer the questions now. It says we are to find in terms of the A and the B, A and or B. That's small a and a small b. So all the answers must be expressed in terms of the small a and the small b. In its simplest form, the vector PQ. Now remember, I always say if you know the position vectors, you can use them to find it. And I do know the position vectors. I know the position vector of the P, and I know the position vector of the Q. And so I can use the formula method to find OR, OP, PQ, I mean, to find this PQ. PQ becomes OQ minus OP because I know both of them. I know this and I know that. So when I know the position vectors, I use it. So this becomes equal to 8B minus 4A. Simple as that. That is PQ, the vector PQ. It means now, guys, that I now know this vector across here. That is now a known vector coming this way. So it's like I know that road now. So the roads I now know are this one up here, and I now know this one because I have vectors for them. All right. So if anything, I can, travel along those roads. The vectors are like roads, are like pathways to go from point to point. That is PQ. All right. 8B minus 4A. All right. If you wanted to do it from the diagram, then we would say, okay, starting at P, I want to go to Q. We would start at P, come down to O first with the minus 4A, and then go across to Q with the plus 8B. So it will be minus 4A and the A and the 8B just the same. All right. So you could have also gotten it from the diagram. But when I know the position vectors, I'm going to use the O time the last minus O time the first. Next thing we have to find is PR. Let's look at the diagram. PR, that's this one. We know it already. We already break it down on this. And so it is just PR now is minus 3A. Okay, we're going in the opposite direction to 3A. Minus 3A. All right. And we broke it down based on this. We have it on the paper why it is that. So PR based on that diagram. And the diagram is a part of my solution. That's why I'm writing these things on the diagram. It's a part of my solution. I'm leaving them on the diagram there. So PR is just minus 3A. PR is minus 3A. Minus 3A based on the diagram. I'm using that method. It's minus 3A because it's obvious, right? I'm not going to do it any other way. 2 marks for that. Then I want the vector RB. RB next, right? Right here, RB. So let's go. How do we go from R to B? Somebody tell me now. How do you go from R to B? Want RB? Tell me. What would you use? What would you use to go from R to B? Anybody? I tend to want to use a vector that you already know. Remember, we just calculated this, or just calculated that. And now they're asking us to go from R to B. Anybody can tell me? You hearing me? You see the screen? I wonder if anybody is there. Somebody say something. Hello? Somebody unmute the mic and say something, please. Let me know that you're there. Because I'm wondering if you're there.
Hi, sir.
Okay.
Yes, sir, we're here.
All right, good. So tell me then now, if you're here, tell me how you go from R to B. Remember, vectors about how you go from point to point. You have to go along the vector direction that you know. So how would I go from R to B on this diagram? Come on, man, this is easy. We do so many questions in vectors now. This should be like second nature to you now. How would you go from R to B on the diagram? I tell you, if you know the position vector of the points, they can use the O and last minus O and first. But we know this, you know, we know OR, you know, because this is OR. But what we did not calculate was OB. So we cannot use OB minus OR to do it. We're not going to use that method because we don't know OB. So we can't use the position vectors to do it, right? We're trying to find RB. So if we know the position vector of both of them, we would use OB minus OR. But we don't know OB. So because we don't know OB, we did not calculate OB, we're going to depend on the diagram now to see how we go from R to B. So tell me on the diagram, how would you go from R to B? Tell me a path that takes you from R to B. That's what this vector is about. How do you go from R to B on the diagram? Somebody tell me. Nobody can tell me how you go from R to B? Yeah, go on, let me hear.
Sir, from R to P and then from P to B.
Exactly. So why nobody taking so long to say that? You go from R to P, and then you go from P to B. That's it. Vectors is about how you go from point to point. So going from R to B, the equals means is the same as going from R to P, as you can see here, go from R to P first this way, and then the plus means and then you go from P to B, go from P to B here. And that will take you from the R to the B. That's all you have to do. All right, and then you want to, most times you use vectors that you know. Look at the diagram now. So we know that this one is 3A. This one is clearly 3A. You can see it on the diagram that is 3A. This is 3A, this one. But what is this one? What is the PB? What is the PB part equal to? I said it earlier. What is the PB part equal to? Like we're not finished class today, you know, because I do so many questions. I do about 20 questions already in vectors. And nobody can answer me this. Come on, man. How do I go from R to B? How do I go from P to B right here? How do I get this vector? Nobody can say that this is just half of this vector that we just found. We found this vector PQ, you know. And the PB is just half of it. That's all, you know. The PB is just half of the PQ that we just found. This is the PQ. The PB is just half of it. No, sir, I mean, that's nobody teach nothing else. No make no sense. Nobody can answer them because simple things here. No make no sense. Nobody teach anything else. I try to teach anything else. Because after doing so many examples, and I said to you, go watch over the video, redo the question. Still this feels like we still just start learn vectors. Still feel like we still just start learn vectors after we do so many examples already. So many examples doing the same thing, going from point to point, going from point to point. Half of PQ, sorry. Half of PQ, just half of this now. That's what half of PQ is, half of that. So this becomes 3A plus half of this is 4B minus 2A. I'm writing it right there. And then you consolidate them. 3A minus the 2A is A. And then you have this 4B. And that is the answer. A plus 4B. A plus 4B. That is the answer. And I can check it if it's correct on the diagram. A plus 4B. Let me check it if it's correct in red and purple. It is saying to go from R to B. I can go A. This is the length of A, you know, this. Along that line, you know. So like I'll go the same length here. So this is A. This right here is about A. Same as this. A. And then 4B is just half of this line now. That is 8B, then 4B is half of that, the 4B. But this is not giving me the right answer. Oh, yeah, this one I'm doing right. A plus 4B. So I'm on the 4B now. Just half of this line, which is around this. See there? That looks like half of this line. About this length, half of it. That's what that length is. So this is A, and this is a 4B. So I can accept this answer as correct based on the diagram. Based on the diagram, I can accept that answer as correct. I am demotivated. I am demotivated. I'm telling you the truth. I am demotivated. And nobody answering. I'm not going to have in a class when people not participating in them. I've already gone through so many questions where all I'm doing is explaining. And I said, go and redo the questions by yourself. Try the questions by yourself. Do them over. And the understanding will come. Well, clearly nobody has done that. And nobody can answer simple question at how you go from R to B. And nobody can tell me that this vector right here, so, is half of this one. Nobody can tell me that, having been told that this is the midpoint. So PB is half of the PQ. We have the PQ here already. I also told you that the way our vectors questions are set up is that the answer for the first part, you tend to use it in the second part. And sometimes if you don't use the second part, you use it in the third part. And when you realize is that this third part, you're using a part of this answer and a part of this answer. So when you're doing a part of a question further down, you're looking to see what part of the first part you can use. That's how the questions are usually set up. I'm not happy right now. I'm not happy. And nobody's answering the questions. Let me copy this down. Just come class and watch me solve questions. And you can't learn that way, guys. You can't just watch me solve questions and explain solving questions, and that's it. Doesn't end there. Though in a sense, I do so many examples, you still can't answer one simple question. It don't make any sense. Might as well me no bother do any. It means that if I do 1 million examples for you, you still can't do one for yourself, which don't make no sense. It just don't make any sense. Look how many I've done, and you still can't answer one simple question. Nobody there quiet. If you go and stay in the class, quiet, I'm going to end the class, and I'm telling you, if you want to just come class to watch me do question, I'm going to end the class, and nobody do it. I'm going to demonstrate to me today, so you can answer question and have some level of understanding, so that we're making progress in this topic. Otherwise, it take a whole week again or 2 weeks again, do it over from scratch. I'm going to come class, come do the work, let me see. Because it don't make any sense. I'm here. I work out all of the June paper. Must be from 2010 all the way up to 2013. The June papers. Plus other questions from the worksheet that I have in there. Right? Doing the same kind of question, and nobody can answer me, tell me what this vector is from here to here, so that it is half of this one. Half of the whole thing. Nobody can tell me that this is just half of this. Nobody there mute. Okay, man. Nobody foolish. Nobody keep my class, you know. Answer questions. I'm not keep my class. Oh. Next question. 2022. More your answer. I ask question, more your answers. whether it's right or wrong, I want to hear answers. But go and come class and watch me solve question, you're not going to go end the class. Oh, I'm telling you from now, don't get me upset. Don't get me upset. Don't get me upset. Answer question, ask question, I want to hear answers. Oh, I don't want only one person answering either. I want to be multiple persons answering questions. I don't care if it's right or wrong. I just want to hear what your line of thought is, so we can improve. Sure. Class just started and get me upset already. This is a question that I sent you the other day. I'm not doing it, you know. I still want somebody to do this question. One person do it and send it to me. I couldn't do it properly what they sent me. And then they said they couldn't do the second part of it. Some part of it they couldn't. Right? They couldn't figure out some part of it. But I do questions similar to these. So this is the question that I sent you in the group. So I'm not going to do it. I'm going to leave this one for you to still do. I want to see your solutions. This class not about me solving questions and you watching me solve them. You know? It's about you being able to solve them by yourself. I just do them as example for you so you can get a feel of how they are done. But after a time, you have to be able to do them by yourself. And I tell you how you're going to learn to do them by yourself and not doing it. You're not doing it. I tell you, redo the questions that I do. Redo them. All right? Redo the questions that I do. And you're not doing them. This example here says, the diagram below shows triangle OPQ. OP is 3U. That's this here. And I break it down for you already. This part is 2U. This part is U. This feels like a question we've done before. OQ is V. Right here says V. All right? And it says Q is a midpoint. Q is a midpoint of OR. OR. So if Q is the midpoint of OR, means that this side is the same length as this and the same direction. And therefore, if I were to put on a vector on that line, means that this vector right here and here going this way is equal to this one, V. Right? Same line, same length, same direction, same vector.
So, sir, OR 2.
Huh?
So, OR is just 2V.
Yeah, so OR is 2V. Good. So OR is 2V. So like you know the position vector of R. Good. All right. Then it says M is the midpoint of this side now. Right? So this side M is the midpoint. So I know what those questions going already now. It's almost like you're gonna need this vector. I feel like I do this question already for this class. Right? Because to get to the first question is asking us for this LM. Asking us for that vector LM. Can't go across here because we don't want the vector going there. But to go from L to M, I can come up here and then go there. But this is half of this one, where I'm able to find this one. This is PQ. Why? Because I know the position vector of the Q and I know the position vector of the P. And then the PM is just half of this. The question is very easy, you know. So the question did not ask us. I see it tells us that OL is 2/3 of OP. And it helps us by putting on the point L. And you can see the 2 parts and the 1 part. So actually break down this line already for us. Right? So this information is kind of redundant, this one. Because I put it on the diagram for us already. All right. Then the question goes straight and asks us for LM. Well, most questions would have asked us for the PQ first. Because to get the LM, you would use the PQ, the half PQ, which is the PM there. But if you look at the diagram, because I don't have the position vector of M, I'm not going to use OM minus OP. I can't use this one because I don't know this. And when you have a vector diagram, you can't use O time the last minus O time the first. You look at the diagram and just see how you can go from point to point. So to go from L to M, I'm going to go this way up here first, which is the LP. And then I'm going to go PM right here. PM. Where the PM is just half of PQ. The PM is half of PQ. But what I can do is just calculate PQ up here first, even though they didn't ask me for it. It is OQ minus OP. Because I know the position vector of the Q, right here, and I know the position vector of the P. So I can use them to find it. So this becomes equal to the OQ is V minus the OP is 3U. So that is the vector PQ. And this PM is just half of PQ. See, PM is half of the whole thing, which is PQ. So I'm going to use that. So this becomes LP plus, and the PM now is half of PQ. Half of PQ. Right? And so now, based on the diagram, the LP is just U. This is just U right here. U. And then I'm doing half of PQ. So I'm doing half of this thing. So I'm doing half of the V, which is half V. And I'm doing half of the minus 3, which is minus 3 over 2U. Then I'm consolidating the values now. This is a half V. That's the only V terms. I'm going to write it first. And then this is U minus 3 over 2U. What do I do to write this out quickly? Write the U as 2 over 2. Make it have the same denominator as that. Then it becomes 2 minus 3. 2 minus 3 is negative 1. So this then becomes minus 1 over 2U. So this is basically saying, you go from L to M. I can go half in the direction of V, and then minus half in the direction of U. We can check if it makes sense. Half in the direction of V, then minus half in the direction of U. If I were to sketch it out on the diagram, this is a whole V. Half of it will be this length. About there, so. But I'm putting it here. See there? About that. That's half of a V, you know? That's half V. Same as this. Half of a V. And then I want minus half U. Now remember, no, this is a U, you know? Let me zoom it up. This is U this way. So half U will be about this. But I want minus half U. So starting from here now, I want minus half U. So it's like I'm here and I'm coming back half U. So this is the minus half U. And this is the half V. So it shows to go from L to M, I go half V this way, and then minus half U back this way. You can see it on the diagram. So when I get an answer like this, I can accept it because the diagram is basically showing me the same thing. So I can accept those answers. All right, I can accept that. Anything else I want us to do? It says I want us to find the vector PR. Let's look at the diagram. How we go from P to R. So I want to know go from P to R. Easy. Somebody tell me we're going to go from P to R. Somebody tell me. We're going to go from P
Sir,
to
is
R.
it in terms of U,
Huh?
in terms of UV?
Everything is in terms of UV. They're always in terms of the vector components. Always.
Yes,
So tell me
sir.
how we can go from P to R. What's the easy way to go from P to R?
That would be what? Negative 3U,
All right. Yes.
because you go down the PO line, and then you go P to R, that's a 2V, right?
Plus 2V.
Yeah.
Plus 2V. Good. Or, because you know the position vectors, you could use that. Because remember now, the position vector of the R, we know it, you know. The OR is 2V. You can see it here, so O to R is 2V. And the OP is 3U. The OP is 3U. So once you know the position vectors, you can use them. O times the last minus O times the first. I'm going to copy this down. So we could use that instead, but I'm just showing you that you could also use a diagram. Let me write it here. But those are equal to that. I can use O times the last minus O times the first. So this PR, vector PR, I can use OR minus OP. You're gonna get the same answer as what you said. So the OR is 2V minus the OP is 3U minus 3U. And I can show you this on the vector on the diagram still. 2V and then minus 3U going from P to R. Look at it. So if I'm starting here, let me shift this up all the way. So if I'm starting here, and I want to go here. Question is saying go 2V and then minus 3R. So 2V starting here will be all the way out here. Same length as this. But I'm putting it up there. This will be 2V still. And then minus 3 is the same length as this. I'm putting over here now, but they're coming down this way. So there. Same result. Minus 3U. So the answer is correct. But 2V this way first and then minus 2U. This is minus because I'm going in the opposite direction to that. All right. So the diagram is correct. The diagram shows me that I'm correct. Okay. So that is it. This is correct. Then it says, prove that L, M, and N are collinear. L, M, and R, sorry, are collinear. L, M, and R. Let's look at the diagram. L, M, and R are collinear. That's these 3 points. And we'll show that they're collinear by just drawing it, You have to show that they are parallel vectors with a common point. They're saying that these 3, you can see it on the diagram as well. All right? They are collinear. So to show that there are the 3 points are collinear, you need to use 2 vectors between the 3 points. You need 2 vectors between the 3 points. So you look to see if you have any of them yet. We should do. We have LM already. LM. We need 1 more vector. So since you already have LM, is either going to use LR or going to use MR. Which one is easier to find? We need LR or we need MR. Because we already know that we're going to use LM. Which of these 2 vectors easier to find? LR or MR? Which one?
Sir, we would have a LR
MR.
All right, so one person said MR. All right, let me hear you.
Sir, we already know if we go from something that P to O, which are on the same line as L to O, which you don't need to go to R, right? You need to go negative U or whatever. So you just use negative 2U and then 2V again. Because I'm already
exactly. The MR can be easier. Because to go from M to R, you're going to have to calculate to go from M to R if you're using these 2 points. It is more work because you'd have to come down here so first and then go across there so like that. You have to calculate because you don't know this straight off. You have to calculate using that piece. But if you choose to go instead, to go from L to R, then you have to calculate nothing. Because you know, say just come down here so with the minus 2U that is there, you have to calculate it. And you go cross there so with 2V. V plus V is 2V. So there's no calculation needed when you're calculating the LR. It is obvious on the diagram that it is minus 2U plus 2V. That is why the LR is easier to find. Come on, man. We do too many examples with this. Similar scenario. We have done now multiple examples with similar scenario and people still choosing the wrong one. So the person who choosing the MR one, you're going to do more work because you have to calculate based on this piece. You don't know this piece. This piece is not shown on the diagram. You have to calculate with it. The LR is easier because you can see the sides. You can see the pieces. You can see that this piece is 2U minus 2u, and you can see that this piece is 2v. No calculation needed. It is there on the diagram. If you're doing MR, you're going to have to calculate. Why calculate when you can just use a vector that you can clearly see what it is? No need to calculate, because any two vectors from the point can work. Any two vectors between the 3 points can be used to show that they are collinear. So I use this one because I already have it. It was worked out in the first part. Then I'm searching for another one, right? Which you don't have another one. So we have to find another, we have to calculate another one, we have to figure out another one. So since we're going to be using LM, let's look at it again. Let's go back to it one more time, see if we can make people understand it. Since we know that we're going to be using LM, remember, you know, we want to show that these 3 points are collinear. So to show that 3 points are collinear, you need to find two vectors between the 3 points. Two vectors between those 3 points. Right? And the two vectors, they're going to be parallel. And because it's only 3 points, the two vectors, there's also going to be a common point. That's what you need to show that 3 points are collinear. Two vectors with a common point. So the bottom line is that you need two vectors. We say we're definitely going to use the LM because we know it already. It was given to us. We calculated in the first part of the question. So we're naturally going to use that. So after we say, okay, we're going to use the LM. Let's mark it. We know we're going to be using the LM. This one. So the other two vectors we can use is either LR or MR. Either we're going to use the vector LR or we're going to use the vector MR, because we're already using LM. We already know that we're using LM. So we're searching to decide which is the second vector we're going to use to show that the points are collinear. You have to do the mathematics the easy way. If I say, okay, let me see how I'm going to get MR. Let me see if I'm going to get MR, I'm going to work out this side and then this side, which I know this side, but this side I don't know it. It's not on the diagram. I would have to calculate. I know it's half of the PQ, you know. I know it's half of the PQ, but I still would have to do some calculation if I'm using MR. So I say, okay, if I'm using MR, I'm going to calculate. So let me try LR instead. If I were to use LR. So okay, if I were to use LR instead, that's the whole vector down there, so LR. How would I go from L to R? Obvious. I would come down the minus 2u there, so, which I know. Good. I don't have to calculate that because I can see it. Then I have to go across here, which I also know that this is 2v. So I have to use the one that I don't need to calculate nothing, which is the second one that I just show you, the LR. I'm not going to use MR. MR requires calculation. LR, you can just look at the diagram and see it. So you don't have to calculate with the LR, so you use the LR. Because I can use any three vectors, any two of the three vectors I can use to show that the points are collinear. Any two of these three vectors I can use. I know I'm using this one already, so I'm going to put it one side. And so it's a decision between these two now. I'm going to use the one that I can find easier, which is this one, because I can look at the diagram and see what this one is. You understand me now? You understand? I'm spending time to try and explain this a little bit more because I think this is like the fifth one we're doing now, which is a same situation where you look which vector is easier to find. And I can't be people still are telling me the wrong one. Come on, man. So the person who said MR, do you now understand why LR is the better one to use? It's about learning and it's not about right, not about getting it right or wrong. When you get it wrong, it's an opportunity for me to know that I need to explain it more, for you to get it, understand it better. That's why I like when people say what they're thinking, what they think the answer is. And if it is wrong, I say, okay, I need to explain this a little bit more. And I try to explain it better, try to explain it more. So I want everybody to understand it. That's why you need to answer questions. Because if you did not say, if somebody did not say MR, then maybe I would not explain it this much for persons who maybe even did not understand it as well before to understand it better now. That's what it's all about. Progress before perfection. Getting a clear understanding of what we're doing. That's just about doing, but to understand what we do, why we do it. And it don't make no sense we encounter the same scenario in questions, right? And don't have a reason for the approach that we use. A lot of the times the question can be done multiple ways, you know. But we say we are in the easy way class. This is the easy way class. We always want to do it the easy way. It don't make no sense you have two ways to do a question, a harder way or a longer way and an easier way. And we choose a harder, longer way to do it. It don't make any sense. You must always choose the easier way to do it. This is the easy way class. All right? So I hope everybody understand this now. You better spend a whole 2 hours on the one question or two questions. And it helps us to understand the topic better. Rather than I do 10 questions and I don't understand nothing. All right? It's about understanding the thing. All right. So we have to use the LM. So we say we're going to use not the LM, the LR. So we say we're going to use the LR because it is obvious from the diagram what LR is. We don't need to calculate LR. LR is minus 2U plus 2V. And so we're using the LM right here and the LR right here. All right? To show that the points are equal in here. So let me write the LR below it, right? So I'm going to copy everything down. Right? So I'm going to write the LR right here. LR is, all right. So instead of minus 2V plus 2, minus 2U plus 2V, because this one has the V first and the U second, I'm going to write this the other way around. Right? Let me rub off the MR because we're not using it. I'm going to write it instead as 2V minus 2U. It's the same thing, you know. The minus 2U, I put the second, and the 2V, I put it first. Because I want to keep the consistency of the order of that one. So I'm going to write it as 2V minus 2U instead. That's what I'm going to do. All right? Then now, I'm going to use these two vectors. I'm going to copy it down. These are the two vectors I'm using for the collinear points. I'll copy it down and put it down here now. So I'm using these two vectors. This one, I'm going to move this one over here beside it, and this one. Put a hand in between. I'm using these two, that and that. So we need to now show that these two vectors are parallel. Those are the two vectors that we're using between the 3 points, you see? The two vectors that you're using must come from the 3 points. They must come from the 3 points. In other words, I could not use a vector with the P in it because P is not one of the points. I have to use the two vectors from the 3 points. So the LM, LM, LR, LR. I have to use two vectors from the 3 points. And when you use two vectors from the 3 points, you're going to have a common point. Right now that I look at it, I know the common point is going to be the L. See, L is on this and L is on that. But to show that the points are equal, you have to show that these two vectors are parallel first. And that L is a common point. And show that they are parallel when you can write something like, for example, LM equals some number. I'm just call it K for now. Times LR. Something like that you want to be able to write. Or the other way around. It don't matter. LR. So LR was a longer one, right? Yeah, LR was a longer one. See, LR is a longer one. So you want to write something like LR equals some multiple of LM. And you want to see what that multiple is. When you get this, it means that the vectors are parallel. What are the steps to get into this? What are the steps to get into this? Come on, somebody unmute the mic and tell me. What are the steps? We have two vectors they want to show that they're parallel. What are the steps? There are 3 steps that we outlined in class. What are the steps?
Sorry, you have to show that they're going in the same direction, right?
What are the steps to show that the vectors are parallel? I have the 3 vectors on the screen right there. So I want to get one of them equals something times the next one. That's what I want. How do I go from these 2 vectors down to that? What are the steps I gave you? Eh? Eliminate the fractions is the first step. Why we eliminate fractions? Because it is more difficult to see the relationship between numbers when they are in fractions. Essentially, you want this side and this side to be the same. You know? That's what you want, you know, so that you can equate, you know. And with these numbers, I can look and see it because this is a half, and I want to get it to become 2. I realize I can just multiply this one by 4. If I multiply that one by 4, it's going to become equal to that over there. When you understand the reason why you're doing what you're doing, then you know you want to bring them to a stage where they are equal so that you can equate. When you equate, that is when you're able to write this as a multiple of that. When you're able to equate, you're able to equate when the vector components become equal. So right now, this is half V and half U. If I multiply this by 4, it's going to become equal to this. Let's show it. If I multiply this by 4, now I'm going to just multiply by 2 alone. You know? But if I multiply by 2 alone, I get 2lm equals v minus u. Then I have to multiply by 2 again. You may multiply by 2 first. That's what I get. And then I'm going to multiply by 2 again to make it become equal to that. Because I said multiply up the small one to make it equal the large one. So instead of multiply by 2 and then multiply by 2, look at these numbers. These numbers easy. I just multiply by 4 instead. So let's multiply by 4 one time. Multiply by 4. When you understand your objective, you'll know what to do. And make the work easier for yourself. If I multiply by 4, this side will become equal to this side, which is what I want to happen. So I can equate the vectors. So when I multiply by 4, multiply this side by 4 first. So I get 4lm equals, multiply this by 4, it becomes 2v. Multiply this by 4, it becomes minus 2u. See, this is 2v minus 2u, this is 2v minus 2u. It therefore means that this equals this now, because the two of them equal the same thing. So now I can equate, because them equal the same thing, I can now equate. Remember the 3 steps. Get rid of fraction. Multiply the small one to make it equal the large one. Equate. We want to get to the stage where we can equate. So if you can take a shortcut to get to the point where you can equate, you take it. When the number is simple and straightforward like this, half to 2. If you want to go from half to 2, you multiply by 4. So I'm equating this to this now. So you can now see that LR is 4lm. So when you equate, you see that LR is equal to 4lm. Because the two of them equal the same thing. This equal and that equal that. So it must mean that this equal this. LR equals 4lm. Right? And then I'm going to underline my common point. Make the examiner see R, L. L is my common point. Then from this, I know 2 things that cause the points to be collinear. Firstly, because one vector equals a multiple of the next vector, I mean that the 2 vectors are parallel. So the first condition for collinearity is that you have parallel vectors. So LR is parallel to LM. That's what this equation means. Then now L is a point common to the 2 vectors. So you're going to write that next, 2. L is a common point. L is a common point. And once you have these 2 conditions, you can draw the conclusion that the 3 points involved are collinear. Therefore, L, M, and R are indeed collinear. You have to state these 2 things. I'm not just putting it on the screen to explain anything. The way I do this question is how I would do it in an exam room. Everything that I've written on the page right here, that's the exact same thing I would have written if I was in an exam room. I would have write this, I would have write the word equate, I would have underlined the L, But I put the bracket right just the same way. But I write the 1 and put that. But I write the 2 and put that. But I write the therefore and write this. What I've written on the screen here is the exact same thing I would have written if I was doing this exam. Same way, but I write it and send it to you. Oh, yes, I set it out there, so. Exactly as I have it there on the screen. That's what I would write if I was in an exam room and send it to you. And I know I will get the full 4 marks for it. Full 4 marks. Anything I leave out, if I leave out this part, chances I won't get the full marks. If I leave out this, chances I will not get the full marks. I might get only 2 marks if I leave out this statement over there. If I want all 4 marks, I have to write out everything here as a part of my solution. Now, whether you want to put the bracket and write it, or you want to write it under here, so no problem. Just make sure you write it. But understand that. Generally speaking, the way how I do the questions on the paper when I'm doing them is the way I would do it in an exam room. And it's the way I'm showing you as a safe way to do it to get your full marks. And that is why I say redo the questions. Redo the questions, watch the video, look at how I do it, try and do it yourself, try and understand it. I'm not telling you to set it out the exact same way verbatim how I set it out. But the content, the general content must be the same. All right? The general content must be the same. I'm showing you the important things that must accompany the solution that you're presenting if you want to get the full marks. I don't just write out this thing every time just to be cute. I write it out because that is the solution you have to present. This is a proof for collinearity. Any question that tells you to prove or show that points are collinear, these 2 things must be stated. That the vectors are parallel and which point is a common point. Then you can make that conclusion. Because if these 2 things exist, then this conclusion can be drawn. And that's how this proof is done. All right? Good. But all right to that?
Yes,
but
sir.
okay? All right. Now look here.
Yes, sir.
The key to all of this, is not just watch me do it and understand when me do it, because I explain what I'm doing each step. The key to all of this is for you to go and redo the question by yourself out of your own head. That is the key to all of this. You'll always explain, you'll always understand it to a point when I do it. Because I'm explaining each step. And a lot of the times I do it, it look easy. It is easy. It's easy for me, because I know it like that. But it's not easy for you yet. So not because it look easy for me, and it look easy when you watch me do it, that don't mean it's easy for you yet. It becomes easy for you when you can do it out of your own head and channel the sequence of thought by your own self, by yourself. The sequence of thought to solve the question. Right? And decipher the things that you need to do by yourself out of your own head. And I'm helping you by doing it for you first. And giving you a video that you can go back and look at and say, okay, this is what Sir did. And when you're doing it yourself and you're stuck somewhere, you go back and look at the video and say, oh, yes, this is what Sir did. All right. And you do it and you go through. And if you have to do the question 3, 4, 5 times by yourself until you can fluently do it by yourself without looking at the solution, that is when you know that you're ready to move on to the next question. You should do each question to a point, to a level, where you can do the question by yourself without looking at anything, without any help from anybody, without any help from any video. So if you do the question the first time and you have to rely on the video for you to move on and move through the question fully, it means that you have not yet done it by yourself. It means that you need to redo the question again. Right? And you have to do it, if you have to do it 3, 4 times, 5 times, until you can do it and complete it by yourself without help, that is when you know, say, yes, I understand this question now. You know, and you can move on to the next question and try and do another one. This thing takes work. It takes time. Mathematics is a doing subject. You have to do. It's not a watching subject. It's not a watch, sir, do it subject. That don't help you. It help you just a little bit. This is just 10% of the help that I'm giving you. The other 90% of the help is what you do for yourself. And I'm giving you all the help that I can give you. I'm showing you how to do it. I'm explaining it. I'm recording it. I'm sending it to you. Give you all the tools that will help you to get through this thing. But if you are not prepared to go and do that part by yourself, then we will forever be stuck behind in this subject. And it doesn't have to be that way. People would say, I have a student the other day, he come tie for first in the Caribbean. And I can tell you, is a student who put in the work. It was shown from during classes. He was disciplined, do all the work, do all the assignment, watch the video, do everything I'm telling him. Right? So it's not a surprise when his name came up as one of the persons who was first in the Caribbean. And the other students who get one with straight A's, it's not a surprise to me the persons who get one with straight A's. Because they don't commit themselves to say, let me just follow sir and do what sir tell me. They just decide I'm going to follow sir and do what I tell them. And once them follow and do what I tell them to the T, they almost guaranteed success. And the success I'm talking about is one with straight A's. Because mathematics at CSEC is a one with straight A's subject. That's what it is, a one with straight A's subject. And if you really serious about getting one with straight A's, you do everything I'm tell you without fail. And it is obvious to me that a lot of you are not doing what I tell you. You're not doing it. You're not doing it. Right? You're not doing it. When people doing it, I'll know. Persons who are doing it, I will know. I will know the persons who are doing it. And the majority are not doing it. Right? And we're coming into December, going into January. This is a serious end of the program now. So the questions we're working on question 10. We look at it now. Right? Based on the topics that I've covered now, you should be able to do number 10 fully. Look at it now. Matrices transformation part A, vectors part B. So every question 10 on exam papers you should be able to do. No. And you should be able to do the number 9s or some of the number 9s. The number 8, sorry, the number 8. You should be able to do some of the number 8. Right? Because it's functions and so on. See? This is coordinate geometry, you know. So you should be able to do number 8 based on where we are in the syllabus, in the program. So when you look at a past paper now, you should be able to do number 8 and you should be able to do number 10. That's where we're getting at. The next topic we're working on is a topic pertaining to number 9. That's what we're going on to next. Trigonometry, including the circle theory business, right? And bearings and elevation, number 9. That's the next topic, this bearings. That's the topic we're going on to next. You should be able to, by the time we finish, by the time we reach the middle of January, right? By the time we reach the middle of January, we should be able to do number 9 as well. So basically, we should, by the end of January, we should be finished and with being able to do number 8, number 9, number 10 on the exam paper. And then we're moving on to number 6, which is the statistics and so on. Right? So we're moving through the papers. Right now, you should be able to do at least more than half of an exam paper, you know, comfortably. You know. You all should be able to do half of an exam paper comfortably if you're serious and do what I tell you. So by the time the exam comes, you are comfortable going into the exam room. Comfortable going into the exam room. Because you know how to do all the questions, because you practice so much. But not to decide on your mind and do what I tell you and practice. You have to. Otherwise, you don't make no sense. You come to this program and come out failing. You don't make no sense, you know. Can't come a program like this and come out fail. We do so much work. It don't make no sense. So if you go on next program, what you do? You get ungraded. It don't make any sense. All right. Enough talking. We go to 2020. Come on, man. Guys, it's time to get serious now. Time to get serious. We're really serious about this program. We're really serious about doing well. You just get serious and do everything I tell you. Can't wait till weeks before the exam. It's gonna be too late for you. Right? You're not gonna learn the stuff properly. You're gonna go in there with gaps in your knowledge. You don't want any gaps in your knowledge. Right? You don't want gaps in your knowledge. Because if you have gaps in your knowledge, it means that you're gonna see a question, you're gonna half know what to do. You think, we must do this again. We must do this again. You don't want that. You don't want that. You want to be able to know exactly what to do. Right? Without guessing. You want to do the question without thinking. That's the level you need to get to. You can do the question and don't have to think what to do. You just know what to do. You get to that level by practicing and do what Mr. Shah said. Do what Mr. Shah said, and you'll be able to do the question without having to think. Because you just know what to do with the question. All right. This is another parallelogram one. Right? They like to set these as well in a parallelogram question. I think one like this is on the classwork, so bear that in mind. This question gives us a parallelogram. It says the vector PQ is U. This vector up here is U. But because a parallelogram is that this side over here is parallel and equal to it, so that side over there is also U. So I'm going to put it on the diagram from now. I like the parallelogram questions because I know right off the bat that the opposite sides are equal in length and parallel. So this vector right here is also U. This is U, so this is U. And similarly, vector PS, this one, is V. The side across here is parallel and equal to it. And so they are also same vector. So this vector is V, then this side up here, the vector across here is also V. That one is also V. Then it says, M is a point on QS, such that QM to MS is 1 to 2. It's basically the same question I said multiple times and give a different letters in them. I can put the ratio on the line, 1 to 2. 1 part, 2 parts. This is 1 part of the line. This is 2 parts of the line. So the total part on the line is 3. So it means that this piece is 1/3 of the whole QS. Simple as that. And this piece down here, this piece down here is 2/3 of the whole QS. 2/3 of QS. Right? And naturally, the question is going to ask, for the vector down here, QS. And then we're going to have to either use this piece, which is 1/3 of QS, or this piece, which is 2/3 of QS. That's what the questions always are. See, first the mark is QS, the vector QS. All right? So we can look at the diagram and see how we go from Q to S. Go from Q to S. Simple. Let me use it in blue. We can come across here so first to R using the V, and then come down this way using minus U. So that will be V minus U. Simple as that. The diagram show me that. So I can go from Q to R and then R to S. All right? Simple as that. But if you look at the vectors, you go V with this V, and then you have minus U by going in the opposite direction to U. So I can just write that V minus U. So this vector QS based on the diagram is just V and then minus U. So let's write minus U. But you understand that? That's QS. Yes, so it's like we know this vector now, guys. We now know this vector. Once you work it out, it's like you know this road. You can go across here so now using fractions of that. You can go across there so now. That's what it means. You now know that vector. It is V minus U. All right? So you now know that road across there. You can travel along it now. All right? If you travel along this piece alone, is 1/3 of this. If you travel along this piece, it is 2/3 of this. And you also want to be going in this direction, this way. Because this is what you have. That's the direction you have. QS is this way. So you want to keep the direction consistent. Do the mathematics the easy way. If you have to go the opposite direction, up this way, then we're going to have to introduce the minus. All right? But to avoid the introduction of the minus, you tend to try to go this way, which is the same direction as the QS. Right? To avoid having to implement the application of the minus for the reverse direction. All right, let's continue. Then I want QM. QM. Question so easy. QM. This is the one now, That is just 1/3 of the QS. It's one out of the three parts. So it's 1/3 of QS. So QM is just 1/3 of the QS. And 1/3 of QS means 1/3 of this. So it's 1/3 of this part and 1/3 of this part. So I don't have to calculate nothing. It becomes 1/3 V and minus 1/3 U. Easy. But I go to that. But okay with that?
Sir. So it's not 1/3. V 1/3.
Oh, good. My mistake. 1/3, not half. 1/3. Yeah, thanks. 1/3. All right. But I go to that.
Yes, sir.
All right. Good. Then now, what does I want us to do? They say show that MR is this. MR. So in other words, we must calculate MR and show so we're done it equal that. All I have done is factorize it with a third. So we need to calculate MR. That's all we need to do now. Calculate MR, and we don't calculate it, and this we must get. That's what it means. Let's look at the diagram for MR. MR. Let's look at the diagram. How would we go from M to R? Somebody tell me. From M to R. What do they do? The question almost the same like this already. Somebody tell me how we go from M to R.
S, sir. Sir, from
I'll go M to S and then S to R. Simple as that. And what is the MR? What is the MS? Sorry. What is the MS?
Of QS.
2/3 of the QS. And you're done. That's it. You can do it right here. So let's do it right here and then copy it down. Let me just do it right here so and copy it down. So to go from M to R, we're gonna go M to S first and then go S to R. The M to R right here, the M to S, sorry, right there is 1/3 of the QS. 2/3 of the QS. So this is 2/3 of the QS plus the SR is U, you know. But I'm not going to put the T in it, plus the U, plus the SR. And we can put in the values now. Because this is QS now. We're just doing 2/3 of it now. So we're doing 2/3 of this and 2/3 of that. So it becomes 2/3 of the V minus 2/3 of the U. That's what the 2/3 of QS is now. And then now we're adding back this SR, which is this, which is U. We'll add back a U right here. And then we're going to consolidate these two values. So this is also 2/3 V comes back unchanged, 2/3 V. And then now we have a whole U minus 2/3 U. A whole minus 2/3 gives you 1/3. So it becomes 1/3 U. But I appreciate that.
Yes, sir.
A whole U minus 2/3 U give you 1/3 U. But the question factorize a third from it. So if you factorize out this third, then we're going to get a third. Out of this, we're going to be left with the 2V. And out of this, we're going to be left with the U. And that's what they gave us. A third 2V plus U. So we're going to copy this down. Now. Cut it. I'll put it down here. That is it. See, the same thing. Well, let me have it the other way around. Same thing. Let me have U plus 2V. We have 2V plus U. Same thing. So we're going to say shown. Same thing. That's it. This and this is the same. 2V plus U is the same as U plus 2V. So that is it. But good at that?
Yes, sir.
All right. Now this part now says T is the midpoint of PQ. It's almost the same question that I asked every time. You know? Show that R, M, T are collinear. Somebody answer me, tell me now. So I want to show R, M, and T. T is the midpoint of PQ. All right. So let's put on the diagram. T is the midpoint of PQ. Right. So let me zoom it up. So T is the midpoint of this side. This side. All right. So what I'm going to do, let me erase these markings. Erase the U. And I'm going to put a point here for the midpoint. And that is where T is. right there. So if that is T, and this is the midpoint, remember the whole thing is U, you know. What is the vector right here between R and T?
Half of U.
Somebody tell me. Half of U. The mathematics easy. What is the vector between T and Q? Same
Half
thing.
of U.
Half of U. Half of U. Half of U. The U I'm cutting in half. The whole thing is U. And the midpoint cuts it in half. Half U and half U. And the question is saying that these 3 points are collinear. Which if you sketch it, you can see it on the diagram. They're on a straight line. So therefore now, I need to use 2 vectors between those 3 points. I have one already because we just work out MR. So I have MR to use already. Let me write them down. I already have MR. See, the same thing again. I have this already. So it's either I'm going to use TM or I'm going to use TR as my second vector. Which one is easier to find? TM or TR? Which one is easier to find? As my second vector to show that the 3 points are collinear. To show that 3 points are collinear, I have to use 2 vectors and show that those 2 vectors are parallel. Because we just calculated the vector MR, I'm going to use it. I'm going to tick that first. I'm going to use the MR vector. I have to use another vector now with the T in it. So that I'm going to use a TM vector or I'm going to use the TR vector. Look at the diagram. Which one is easier to find? T to M
TR.
or T to R?
Yeah.
TR. TR easier to find. Because you can clearly see to go from T to R, I'm going to just come up here so first with a half U and then just go across this with a V. Good? So we're going to use the TR clearly. So let's write it. The TR we're going to use, which based on the diagram is half U plus V. Half U plus V. All right? And we're going to use the MR that we just found. The MR that we found was, what was it again? It was 2/3 V across here and 1/3 U up there. So that's what we got. 2/3 V. Now this was 2/3 V, you know. To come from here to here, that's a 2/3 V. And then to go from here to here is a 1/3 U. I know this question is a question I'm set all the time with different values, different letters, but it's the same thing that's set all the time. So the MR is 2/3 V plus 1/3 U. So these are 2 vectors I'm using. So I'm going to copy them down now. Show that the points are collinear down here. I'm using that one. And I'm using that one. This and this. All right. So the only difference is that this one has the V first, and this one has the U first. I can actually just switch around one of them. Let's switch around this one. So TR is the same as V plus half U. I'll just switch them around to let the components appear in the same order. All right. So I now want to show that these 2 vectors are parallel, and clearly the R is going to be my common point. That's how we prove collinearity. All right. So tell me now, what do I do with those 2 vectors?
So we try and get rid of any fractions.
Good. So how do I get rid of fractions out of this one first? What do I do with it? Let's zoom it up. How do I get rid of fractions out of this one first? What do I do? How would I get rid of these fractions out of this one?
Multiply by 3.
Multiply by 3. Multiply by the 3 that is here. That will cancel those 3. So multiply by 3, multiply this side by 3 first. We get 3 MR equal, multiply this by 3. The 3 cancel. We get 2V. Multiply this by 3. Cancel the 3 and we get U. So I now have that vector. This one now, I want to get rid of the fractions out of it. But I could just, we want to get rid of the fraction out of this one. So what do I do with it to get rid of the fractions out of this one now?
Multiply by 2.
Multiply this one by 2, the fractions will be gone. Now multiply by 2. Remember, I multiply this side by 2 first. Don't forget that. So it becomes 2tr equal, multiply this by 2. It becomes 2v. Multiply this by 2. It cancels a half and you get plus u. Now look at the two vectors now. This one now and this one. What do we see? What will we do next? What do we do next? What do we do next? Somebody tell me what we do next. What happens next?
So to look if they're equal,
They are already equal. You see, this are 2v plus u and this are
equate them,
2v plus
equate
u.
them.
Equate.
Once they are equal, you equate them. The two of them equal this. So you equate this to this. Equate them to something there. How much of them you have to do for to know that? And if you go and do the questions over by yourself, so you know what to do by doing it yourself. That's what the problem is, not doing it yourself. We reach a stage now we can equate. Once they are equal, we can equate. We have to multiply up none again. They are already equal. So now that they are equal, we equate them. And we are now able to write that 2tr, put it in blue. The 2tr is now equal to the 3mr. Now, this means that they're parallel now. Because if I can divide by the 3 on the here, 2 on the there, so. And you'd have one of them fully equal to a multiple of the next. But I don't have to do that. You can leave the 2 right there. So it still means that the parallel, one vector equals a multiple of the next vector. That's what it is. I don't have to do anything else. And I can underline my common point. And since I have one vector equals a multiple of the next vector, it means two things. It means firstly that the parallel. So the first condition for collinearity is that the parallel. TR is parallel to MR. And then the R is a common point. The second condition for collinearity is to have a common point. R is a common point. And because you have these two things happening, we can draw the conclusion. And so therefore, the points involved R, M, and T are indeed collinear. The points are collinear because these two things happening. That's why the points are collinear. And that's it. That's the end of the proof. Better go to that.
Yes, sir.
All right. Let's go and do another one. More maths equals better maths. But not watching me do more maths, you doing more maths. So I'm just doing them to help you when it's your time to do them. I want when it's your time to do them, you're not toiling over them. Because at least you have a solution, you have somebody to explain it already. So if you're stuck, you can just go back and look at the video and redo it yourself. I'm making it easy for you now. When we get to March, I'm not doing anything for you first. You're going to have to do them first. And I do them after. That's how we're going to be doing it in March. Between now and March, I do them first, show you how they are done, and then you go and do them afterward. But if you don't go and do them afterwards, how are you going to do them first in March? So that they can do it in the exam. How are you going to do it first in March if you're not able to do them after me now? Or if you're not doing them after me now? You have to do the questions after I do them. You have to do the questions after I do them. That's how this program works. So if you're not following the program, you're cutting yourself short. Right? You're cutting yourself short if you're not doing what I tell you. 2019, January 2019. Another vectors question here. This time we give us a diagram. That they leave the diagram kind of blank, like. Start it, O and A for us, right? It says OABC is a parallelogram. That's a parallelogram. Now watch me now. See, from them start with O and A right here, so you have to put B here, so, and C here, so. Because the orientation must remain consistent or you label a diagram. That's the first thing I'm telling you. So since them put A here, so you put it on the B and the B has to come here and the C has to come here. You cannot go and put B down here, so. Since you have A and B here, so A and O and A there, so you can't put B down here, so, and C there, so. You can't go O, A, B, C. No, you cannot label a diagram that way. You label a diagram around in one orientation. So once right here says OA, it means that the orientation is this way. This has to be B, this has to be C. But understand that?
Yes,
Everything
sir.
important.
Yes,
Good. Everything important. All the label diagrams, the orientation must remain consistent. Can't go zigzag and crisscross, especially in a polygon. A polygon must be labeled with one consistent orientation. So the B has to be here and the C has to be here. So anybody do this question and put the B down there so and the C down there so, already in problems. They are already in problems. I'm telling you. Okay? All right. So let me go and put it the right way. So they put the A here so far for a reason. Because they want it to be labeled this way. All right? I don't want everybody doing something different. So the B is here and the C is here. However, clockwise orientation. All right. It says X is the midpoint of AB. So X is on this side, AB. So if you don't put the B down there, so you know, and down there, so you don't want to put the X in. See, you'll be in problems. Right? So it is expected that you're going to label it the right way. All right. So X is the midpoint on here of AB. So put in X. So X cuts this line in half. 2 equal halves, right? And it says Y is the midpoint of BC. So it means that the Y is the midpoint of this side. So basically gonna put Y right here. So Y cuts that side in half. Then it says OR is A and OC, sorry, OA is R, small r, and OC is S. Those are the vectors now. So the vector from O to A is R, small r. I'm gonna put on the diagram right here. And the vector from O to C is S. That's this side, is S. Let's complete the diagram. All right, let's complete the diagram. Now, this whole side is also S. But this is the midpoint. So somebody tell me, what is the vector from O to X right here? Right here, what is it? What is that vector? OX. And what is the vector XB? It's a parallelogram. So this side and this side equal and opposite. They are equal in length and they are parallel. So they are equal vectors. So since the whole of this side is S, where this side is also S. So tell me, what is the vector from A to X right there?
There, that would be A half S.
Half S. What's the vector from X to B?
That would also be half X, right? Because it
Half
the other half.
S. All right, so this vector is R. Then this vector is also R. And this is the midpoint. So tell me now, what is the vector from C to Y?
half R.
Half R. So I'm filling out the diagram so that I have all the information I need on the diagram. So I can see how I go from point to point. That's why I'm doing this. This point down here, so it's C. And this vector here as well is what?
Half R.
Half R as well. All right, so the more information you can put on the diagram, the better for you. So you can see how you go from point to point. That is your aim. To see how you go from point to point. All right, so fill out the diagram as much as needed, right? This question says no. This question says no. Given that, mute the mic, please. Mute back your mic. OX plus OY is equal to K times R plus S, where K is a constant. Using a vectors method, find the value of K. Now to do this, guys, all you have to do is calculate this, and so we can see exactly what the K is. Let's calculate OY and calculate OX and add them. So tell me now, based on the diagram, what would be OX be equal to?
OA, that's a R and half S.
R, mute the mic, please. Mute the mic. R plus half S. And what would the OY be equal to?
That would be what? Would it be negative R and
the diagram? OY. OY. O to Y. O to Y. Look at the diagram. How do I go from O to Y?
Oh, wait, maybe I go from A. It's gonna be S and then half R.
S plus half R. Then I'm adding them. So I'm adding these now, right? So I can say, therefore, OX plus OY would be equal to what? I'm adding them. So I'm adding up everything, yes or no? Because if I'm adding these two here, it means that I have to add up everything here, don't yes or no? So I'm adding the R values, which is R plus half R. R plus half R is what?
1.5 R.
1.5 R, or 3 over 2 R. And S plus half S, yes, so is what?
1.5 X, or 3 over 2.
Which is 3 over 2 S. And I'm trying to get it to look like this. What do I do now with these two vectors, with those two, to make it look like this? What do I do? I'm trying to get it to look like this so I can see what the K is. What do I do with this now?
So you get rid of the fraction, right?
No, man, we're not eliminating fraction, man. I'm trying to see what this is in terms of that. I'm not doing any collinear parallel vectors now. I'm just trying to see what this is equal to compare to this so I can figure out what the K is. And so far, this is where we reach. In working out the OX plus OY, we reach here, so we're supposed to reach something looking like this. So what do I do with this now to make it look like this? What do I do with it? Factorize the 3 over 2. Factorize the 3 over 2. If I factorize the 3 over 2, I'm going to left with R out of this one plus S out of this one. And now it look like this. So based on that, now what is my K? What is K?
3 over 2.
K equals 3 over 2. The mathematics is easy, you know? The mathematics is so ridiculously easy. Therefore, the K equals 3 over 2. Listen, guys, all I've done in this question, they tell me that OX plus OY is equal to that. So I say, okay. And they want me to tell them what R is. So I say, okay, no problem. All I have to do is work out what OX plus OY is for myself. See what it comes out to, and then compare it with what they say that it is. I see that we remember 3 over 2, them about K. So K equals 3 over 2. That is all, you know. That is all. Let me say it again. They tell us that OX plus OY is equal to this. And we must tell them what the K is. See? Find the value of K. We say, no problem. All I'm going to do is work out what OX plus OY is by myself. And see what my OX plus OY is and compare it with Fidemon. And then I see what the K is. So when I work out the OX, I work out what the OX is, then I work out what the OY is, and I proceed to add them because I'm trying to form this. When I add them, we get this first. But they don't have that. They have something factorized with the R plus S. So look at it. The number to factorize is 3 over 2. So we factorize the 3 over 2, we generate the R plus S. So where they have a K, I have a 3 over 2. So K equals 3 over 2. Simple as that. You develop these things and you know what to do with practicing. Practicing. Because you know you encounter these questions, you do them, and you do the questions, you know what to do. Through practicing, you don't have to figure out stuff. The more you do, you don't have to figure out stuff. As you see the question, you know the nature of the question. But the higher the volume of questions that you do, the more exposure you get, the more you know what to do when you see a question. All right? And I'm helping you to cover that wide variety of questions by doing a lot of them for you, but you have to go and redo the question by yourself. Like this one, you're going to do it over by yourself. Do it over by yourself. And watch the video if you need to see what I did. The explanation I gave. So you get one like it again by yourself next time, you know that is the same approach you use. All right. Next question, all question done. That was all. The easy question. Done. That was all. I wanted nothing else. So see this one done. Nothing else to do. Simple as that. All right. No calling your point, nothing. That is it. Let's go to 2018. 2018. I want to see the student who made the merit list this year, for the Caribbean or Jamaica. I come first in them school or something. I want to see the student. That's what I was looking for in my classes, students to do that sort of stuff. Come first in them school. Right? I come first in Jamaica. I'm not first, you make the top 10 list. And I'm saying anybody will absolutely come first, but you want to be one of the top students. You want to make a top 10 list, you want to make the merit list. Right? If you seriously want to achieve something like that, then you put in the work. You're just gonna get it like that. Put in the work, attain mastery in the subject. All right. So this is number 11 on 2018. So this one like a calculation one. Don't send the diagram anywhere. So give us these vectors. OP is this, PQ is that, RS is that. And I want us to determine OQ. You could do this question already, you know. You see, I'm at CXC, sometimes I repeat the question. So when you practice a lot, you know, everything just becomes so familiar. It's like we do it already. To get the OQ, because the OQ is in this, we can split it and get it, you know. We can look at it another way. If you want to go from O to Q, you can say, okay, I can use these two vectors. But this one takes me from O to P, and then this one takes me from P to Q. So I can go from O to Q by adding. I can say, okay, to go from O to Q, let's write it out. I can go from O to P first, and then go from P to Q. So you go from O to P with that, you go from P to Q with that, and get the OQ that way. 3, 4, and minus 1, 2. And so the answer is 3 and minus 1 is 2. 4 and 2 is 6. And so OQ is 2, 6. But I can show you another way. We split the vector equation that has Q in it. This one. I can first write. Mute your mic, please. Mute your mic. Mute your mic. Mute your mic, please. PQ is minus 1, 2. And if I want to get OQ out of that, I can split it. I'm showing you another way to do it. Right? I can split the equation that has the OQ in it. Because this equation, it has P and it has Q in it, you know. But we already know the position vector of Q. So this is the one that we don't know. So we can split it. We're going to split this side. We split it into O and the last minus O and the first, which is OQ minus OP. Split this side and put it back equal this. which is a minus 1, 2. Then to leave OQ as a subject, I would take the OP and add it over here. And so I will get OQ equals the minus 1, 2 plus this OP. And I'm just going to write what OP is beside it. OP is equal to the 3, 4. And so you see I'll get the same answer. Because this then will work out to be, let me shift this over a bit. I like a bit more space. Right? So if you work this out, you're going to get the same answer. Because it becomes minus 1 and 2, minus 1 and 3, which is 2, 2 and 4, which is 6. So whichever way you want to use, result is the same. All right, almost the same amount of work. I think maybe this one is the easier one based on the thing. You'd have a split none. Then down here now it says show that OQ and RS are parallel. Show that OQ is parallel to RS. So we're doing the OQ, which is this one, and the RS, which is this one. All right, so those are the two. So we have the RS equals 1, 3. And we have the OQ equals 2, 6. So you can clearly see that this one is the big one is 2 times this one. I'll put another way. To get this one to be equal to that one, I have to multiply it by 2. And that is when they become equal. I will get 2RS equal, multiply this by 2, we get a 2, 6. And so this equals that. As the two of them equal 2, 6. So we can now equate. And when we equate, we can write that the OQ equals the 2RS. The big one, which is OQ, equals 2 times the RS. That is their parallel. That's what makes them parallel. Because one vector equals a multiple of the next vector. When one vector is a multiple of the next, the vectors are parallel. And that's how it shows that they are parallel. It says, given reason for your answer, we can state it here, they are parallel OQ because OQ is a multiple of RS. That's why they're parallel. That's what this means. OQ is a multiple. It's twice. That's why they're parallel. When two vectors are parallel, one is a multiple of the next. That's it. All right, because them say given reasons, that's why I wrote this. So you write this equation, which means that they're parallel, but because it also says given reasons, I wrote out that statement there. I have to make sure that I get my marks. All right, it's a different question. It says XYZ is a triangle and M is the midpoint of XZ. Now notice, guys, on this question. They have not shown me a triangle. They tell me of a triangle, but they don't show me it. What do you think I'm going to do? What would you do? The question tell you of a triangle, but them don't show you none. And it says M is the midpoint of XZ, and the vector XY is A, and the vector YZ is B. And they start to ask you questions about it. What would you do in the exam room? What would you do?
Draw a triangle.
Draw one triangle. Draw one triangle and put on the points on it. XYZ, any triangle. You can draw it any way you want to draw it. Any triangle. Draw it easy so. XYZ. I would draw a simple triangle like so. X, Y, Z. Then I'm saying M is the midpoint of XZ. XZ is this side. I'm going to put M right here. Then I'm saying XY is a vector A. That is up here. XY is a vector A. I'm going to put A on it. I'm going to draw the triangle so I have a visual of what is happening. I'm not going to work blind. You mad? And vectors, I know that diagrams help you in vectors. Nope, not going to work blind. So if you tell me of a triangle, you don't draw one, I'm drawing one. I don't have to draw this. Any way you draw a triangle, you know, you're good to go. You can draw a triangle any way. Just draw any triangle, it don't matter. All right, it don't matter. I'm just drawing this, my triangle like this for no particular reason. I'm just drawing it like this for no reason at all. I've chosen to draw it like that. Maybe another day, maybe tomorrow if I do this question again, I draw it another way. I might draw it so next time. All right, I draw it any way I want. But this vector is A. And then the vector Y to Z, that's down here, is B. All right, ready to work. Question says, express the following in terms of the vectors, in terms of A and B, simplify answer where possible. First vector I want is XZ. XZ. Tell me, how go from X to Z, going along the vector direction that we want. X to Z equals what? Talk to me. Look at the diagram that we have drawn. Make it easy when you can see it on the diagram. What is the vector X to Z? Somebody tell me what is the vector XZ? Huh?
M.
M is not a vector, boss. M is a point. M is the midpoint. M is the midpoint of XZ. I'm asking you for a vector. M is a point. Look at the diagram. What is the vector XZ? What is vectors? Vectors is how you go from point to point. How do I go from X to Z? I ask for the vector XZ. Look at the diagram and tell me how do I go from X to Z? Which vectors? See the vectors them here that me know. These are like roads that take you from X to Z. So tell me again, how do I go from X to Z? Going along the road that you know. You can't come straight across here, so. Because I don't have no vector taking a straight across there, so yet. The vector that you know is this one and this one. So look at the diagram. How can I go from X to Z?
X, Y, Y, Z.
Simple. Come up here, son, and go down there, so. That's all. You go X to Y, and then you go from Y to Z. That's what vectors is, just how you go around the diagram from point to point, going along the direction that you know, the vector directions that you know. The only directions we know is this one and this one. So clearly, A is going to take you up to Y, and B is going to take you down to Z. Right? I didn't have to write this in. Okay, look at the diagram and say it's A plus B. You know? Look at the diagram and say go up A and then come down B. That way there. So this is A plus B is the answer. That is XZ. But understand that?
Yes, sir.
All right. Next question. MY. Look at the diagram now. See it here now? MY. How do I go from M to Y? MY the more next. Remember now, we just worked out XZ, you know. So it's almost like we now know this road. We now know what this road is. Because we have it right here. We just work it out. It's like we know this road now. XZ. Right? So going this way, from X to Z, this way, is this vector, A plus B. Is this vector. So we now know it. All right? And we also know that this is a midpoint. So that cuts that A plus B in half. This M cuts it in half. So it means that this side is half of the A plus B. And right here is half of the A plus B. So you now know that. I don't have to put on the diagram. You now know that. And the question now is asking me, how do I go from M to Y? Look at the diagram. How would you go from M to Y? Somebody tell me.
MX, then XY.
MX. I can go
And then
MX. All right, I'm going to do MX. So go, all right, let's do it here. So to go from M to Y, I can go M to X and then X to Y. Good. Somebody tell me if they see any other way we can go from M to Y. Somebody tell me. So somebody just told me that I can come here, so come back to X first this way and then go up there, so which is good. Fine. Is there any other way to go from M to Y?
So,
I'm
so from M to X and X.
Somebody have that one already? M to X.
M
No, to Z, I mean. Z.
Good. So tell me
M to
now.
Z and then Z to
M
Y.
to Z and then Z to Y.
Z to Y.
Good. So anyway you choose, the answer must be the same, you know. So if somebody choose to come here, so, and then there, so, that's okay. If somebody choose to go here, so, and then here, so, that's okay. Anyone you use, the answer must be the same. So let's do the two ways then. So the other person said, I can go from M to Y, I can go M to Z, and then Z to Y. Whether I'm going to do it this way or this way, the answer must be the same. So let's do it both ways, just to show. All right, look at it now. This one. What would be the MX? Look at the diagram. What would be the MX? What would be the M to X this way? Remember, you know, the XZ is in this direction, you know, and it is equal to this. Right? And the MX is half of that, you know, but it is in the opposite direction. So tell me then, what would be the MX part here, so to come here, so the MX, right here, so this first part, what would it be equal to? Somebody tell me, what would the MX be equal to? To go from M to X, knowing that the XZ out here, so is A plus B, and also knowing that the M to X is in the opposite direction to this, and also knowing that this is just half of the whole thing. Come on, simple, come on. Remember?
so sorry, would be minus
Minus
no, yeah, minus half XZ.
Minus half of XZ, good. Yes, let's write that. Minus half of XZ. Good. Because the minus means that they go in the opposite direction. You're taking half of the XZ. Good. All right. And we know the XY. XY is just A, right? Up here, so don't it? That's obvious, right? XY is just A. Agreed?
Yes, sir.
A. All right. So this calculation then is done by taking minus half of this, don't it? Minus half of this, don't it?
Yes,
Agreed?
sir.
Good. So it's going to be minus half of the value and minus half of the value there. So it's minus half of A and minus half of B. That's what this is. And then I'm adding back this A down here, so plus A. So let's consolidate the values now. Equals, let's put under here. This A minus half A, give me half A, don't it? A whole A minus half A, give me half A. And then this minus B not changing with anything. So I'm put it back here. Not changing. So I get minus half B. That's the answer I'm having. Half A minus half B. Let's see if it makes sense on the diagram. The same. It is saying to go from M to Y. I must go in purple or black. Starting from here to here. What this answer is saying? I must go half A and then minus half B. Let's see if it makes sense. So I'm going half A. Bam. That's half A now. Take me to here. And then I have to go minus half B, which is this piece. That's correct, you know. The answer look good. This is will be half A up here, so, and then minus half B. Because I'm going in the opposite direction to B when I go this way. That's why it is minus. So the answer looks correct. Half A minus half B. But let's work it out the other way now. This way. Let's work it out the other way. Must get the same answer as this, you know. Must get the same answer as that, if it is correct, right? Let's go. So M to Z. Let's look at the diagram. What is MZ right here? So what is MZ?
It's just half X
Half of this.
positive too, because it's just going in the same direction.
Good. So it's just half of the XZ. So this is half. This is half of the XZ. And then what is the YB? YZ? No, the zy. What is the zy? The zy. Z to y is what? You can give me in terms of the b. What is z to y?
Z to Y are just negative.
Negative b. So for the z to y, I'm just gonna write this plus zy. I'm gonna write minus b instead. Because that's what this is. The zy is just minus b. Let's put in the values now. So the half of the xz is half of these values. So I'm going to write half a and half b. I'm going to write half a and half b. And I'm subtracting back this b minus a whole b. Got it carefully now. So this becomes, this is the only a term in it, half a. But this is now half b minus a whole b. This minus a whole b, I can write it as 2 over 2. So it becomes 1 minus 2. 1 minus 2 is what? Negative 1, don't it? Agreed? 1 minus 2 is negative 1. So it becomes minus 1 over a common denominator of 2 over 2b. Same answer. Same answer, even though we went the other way. Answer is the same. So you see, guys, vectors is just how you go around the diagram from point to point. And you want to go along the vector direction that you know, the answer is going to be the same. It don't matter which route you take. It don't matter which route you take. Once you start at one point, you go around the diagram. So in this case, I'm using x as an intermediate point. In this case, I'm using the z as an intermediate point. So I'm going from m to, over here, I went from m to x first, and then went from x to y. Over here, I went from m to z first, and then go from z to y. The end result is the same. The end result, which is a resultant vector, is the same. But how to go to that?
Yes, sir.
All right. All right. Let's look at another one. If there's any other part to this. No, the rest of it is no matrices. All right, that finishes that question. What time is it now? All right. So now after one, we started a little bit after, so we can maybe just do one more question. How long are we going? And 2 hours yet?
Yes, sir. About 2 hours.
2 hours, sir.
You
2 hours.
sure?
Yes, sir.
Oh, so I'm not going to want done the class. So. No one done the class. No one
Little
the
bit.
class done now. No one done the class.
Don't
Don't it?
read it.
Don't wait dinner. Just quite fully reach 2 hours. We got about 1 hour 58 minutes. 1 hour 52 minutes. Look on 2020. Which one was it? 2018 or 2017? More maths equals better maths. Let's do one more. I'm too lazy. Can't get good by being lazy. Right? I have to learn not to be lazy. Can't get good by being lazy. You have to decide to put in the work. Right? If you're good when a young man send and show me his plaque. First in the Caribbean, first in Jamaica. You can imagine him feel good. I'm going to the same class like you, getting the same teaching like you. The only difference that he was prepared to put in the work. Not him alone. There are other students over the years who do that as well. Students who put in the work always get the results. You know, that's a one good thing about I can tell about CXC. You know, once you put in the work, you know, you get the results. And the more work you put in, the better your results. The more work you put in, is the better your results. So you have to decide what kind of results you want. You know, in a sense, you come into a class like this and a program like this and don't get the best grades possible. Like you'd have wasted parents' money. You'd have wasted my time. All right? So make sure I say waste my time because I give a lot of my time for free. I can tell you that. You understand? I give a lot of my time for free. So I'm not giving them money. I'm giving a lot of time for free. All right. So this question says the graph below shows 3 points, P, Q, and R relative to O. So these are the points, P, Q, and R. And they're all relative to O. So, you know, it's like going to those points from O. That's what it means. Boom, bang. So this one is because it's on a graph, right? It says that write down in the vector form the vector OP. So firstly, this is the point P. The P has coordinates 4, -1, 4, -1. So the position vector will have the same values, 4, -1 as a column vector. Simple as that. Okay, and just for good measure, write down the others. Q is a point 0, 2. Q is a point 0, 2. And R is the point 3, 7. 3, 7. So R is the point 3, 7. Because once we know the coordinates, we also know the position vectors. Question wants us to tell in the vector QR from Q to R. Can you look at the diagram and know, you know? From Q to R. I just need to count how many units this way and how many units up. Go from Q to R. That's vectors, you know. So I go 3 units across and 1, 2, 3, 4, 5 units up. 5 units up. So I can tell you that QR is 3, 5. But I can calculate it as well using O times the last minus O times the first. Because if I want to get QR using position vectors, it will be OR minus OQ. And the OR, because this point is 3, 7, then the OR will be 3, 7 with the same values, minus OQ, and OQ will be 0, 2 with the same values. And so it will be 3 minus 0 is 3, and 7 minus 2 is 5. Same 3, 5 I got up here by looking at the diagram. That's why I like diagram vectors questions, because you can see that your answer is correct. All right. Now, if I'm in the exam room and I draw this and put this as my vector, you have to give me my marks, you know. Yep, I have to give me my marks. I did not have to calculate it this way. All right. I could use a diagram to do it, because they gave me a diagram. They can't tell me not to use a diagram. Then down here says determine the magnitude of the vector. Up here, they basically asking me for this length. How long is this? That's what the magnitude is, you know. So again, I can work in this triangle. I use Pythagoras' theorem, and this then will become equal to the square root of 3 squared plus 5 squared. But then we can use the vector formula method for modulus, right? Which now, since the vector is this, again, is the same thing. The magnitude or the length. The magnitude is talking about the length, which is a modulus. So it's written like this. The modulus of QR comes equal to the square root of this value squared plus this value squared. This is 25 and 9. 25 and 9 is what, 34? This becomes square root of 34 units. That's it. I don't have to work this out full. I can leave it like that, because it's not a perfect square number. I can leave it like that. All right. That's the magnitude or modulus of QR. Down here says now, on the graph provided on page 32, draw the vector OS 7, 2. Now, if OS is 7, 2, as a position vector of S, it means that the point S has the same values, not 7, 2, 7, 4. So put this on the point 7, 4. Put the point 7, 4 and then draw the vector from O to S. As I said, it's a draw the vector. So you need to draw the line from O to S. 7, 4. So I'm going to put the point 7, 4 on the diagram. Where is that point? Let me take these off. 7, 4, 7 up to 4 right here. So that's 4 there. So 7, 4 is this point right here. That's where S is. Let me take this off. That's where the point S is located right there. And the vector that I'm going to draw is from O to S. I have to draw in this vector right here with a straight line. You have to show this on the graph. You have to show it. You can't just put the point S and stop. You have to show the vector. That's what the question asks for. I'm going to put an arrow point in this way, put OS, and put that on it. See? So the vector OS is 7 to the right and 4 up. That's the vector OS. So I'm marking it like this. I'm doing this on my exam paper now, guys. Just like that, and put the vector right here as well. That's the vector OS I want to show on the graph. All right, and it's now show that PQRS is a parallelogram. Now, if it's a parallelogram, it has 2 pairs of equal opposite sides. Equal opposite parallel sides, I should say. It has 2 pairs of equal opposite parallel sides. So if it's a parallelogram, which one? PQRS. Let's mark it out. PQRS. Let's mark it out in a different color. PQRS. Well, all I need to do is join here and join here. We're talking about this thing that I'm marking out in red. PQRS. They're telling us that it's a parallelogram. So, if that is a parallelogram, what will happen is that this vector from P to Q will be equal to the vector from S to R. And the vector from Q to R will be equal to the vector from P to S. That's what you have to show. So if it's a parallelogram, let's write it out. The vector PQ this way, PQ will be the same as SR. And also the vector QR up this way will be equal to the vector PS up that way. QR will be equal to PS. So you just show these 2 things to show that it's a parallelogram. Let me copy it down. 2 things that we need to show. Guys, you have to show that it satisfies the properties of a parallelogram. So that's what we're showing down here. That's what we need to show. We need to show this. Need to show this thing. All right. All right. So what we have already? Let's underline what we have already. So we have QR already. So we calculated it here. QR. So let's underline what we have already. We have QR already. What else do we have? We have another vector. That's it. We don't have anything else. We've calculated the rest of them. All right. So we have QR already, right? So we need to calculate PS now and show that it's the same. So PS is OS minus OP, which is 7, 4 minus OP. What was OP again? OP was 4, negative 1. 4, negative 1. 4, negative 1. Work this out for our PS. We must get it equal to the QR now. So 7 minus 4 is 3. And 4 minus a negative 1 is 4 plus 1 is 5. See? So this is equal to the QR because 3, 5 was also equal to the QR. So we have now shown that PS equal QR. So the first part already, this part. We need to work on this part now. So we're going to work out PQ. Let's do it here. So PQ is OQ minus OP. And the OQ was what again? 0, 2 or something like so? Yeah, 0, 2 is the OQ. See here? OQ 0, 2. And the OP is 4, negative 1, right? So we're doing 0, 2 minus 4, -1. This works out to be -4, 3, because 2 and -1 give you 2 plus 1 is 3. That is the PQ. This side. We need to work out now the SR right here. So the SR now is equal to OR minus OS. What is the OR again? The OR was 37. So it's 37 minus the OS, which is 74. I've worked this out to get 3 minus 7 is -4. And you get 7 minus 4 is 3. So you see, it is the same as the PQ. What I mean call the same thing. And therefore, we have shown it. We have shown this. This is true. We show this part is here at true already. And now we just show that this is this. So we can say, we don't have a lot of space, but that is it. Right? We'd say, therefore, put a different color. PQ is equal to SR. So I've shown this, and we have shown this one, that this is equal to this, which are the things that we need to show to prove that it is it's a parallelogram. And then you could write a conclusion that therefore, could write that therefore, which parallelogram is it again? PQRS. Therefore, PQRS is a parallel, that means parallelogram. That's like a symbolic way to write the word parallelogram. That's it. Parallelogram. Parallelogram. That's it. But I understand that? It's a parallelogram.
Yes, sir.
When a question asks to show that a quadrilateral is a parallelogram, you have to show that the opposite sides are equal vectors. Because when they are equal vectors, they are equal in length and they are also parallel. Equal vectors have same magnitude and same direction. So if a quadrilateral is a parallelogram, then the opposite sides, you have to show that the opposite sides are equal vectors. Once you can show that the opposite sides are equal vectors, it means that you have a parallelogram. You have two pairs of equal opposite vectors. Right? The opposite sides are equal vectors. And you have two pairs of them. And that's it. All right, guys. I'm going to stop it now. Okay. I don't want y'all waste the time, waste what we're doing. All right. You need to just do what I tell you. Redo the questions. Practice. All right. You have to do it. Redo the questions. You have to do them multiple times. You do them multiple times. That's how it works here. All right. Well, we'll get to March. You'll have to do all the questions by yourself first before I do them and explain them to you. All right, we're getting ourselves ready and prepared for that. So I want you to go back. I want to send the video in the group. You're gonna watch over the video. You're gonna do the questions. All right, that's what you have to do. We do all the questions. All right, and then I want you also to do the question that I sent in the group. That one that I skipped over. You need to do that question that I sent in the group. Everybody need to do it. Send it. Let me see your answers. So that when we come to class tomorrow and Monday, I'll know what to emphasize. All right. Okay. Bye, everybody. Have a good day. All right. Bye-bye. All right. I'm going to end the class now. Bye.